I sense a little distraction. In order for me to answer Sam's question and slide this up a little bit, let me cut back a little and say, are there any questions on numbers 1 through 4? Go ahead. Okay, well, you look for a common factor, agree? Do you see one?
No.
Okay, so we go to plan B.
Yeah, I did plan B.
Good. So did you multiply the 36 by 2 and come up with 72? There would be the problem. Once you do that, you just got to factor it. Now, number 4 is a particularly good question. Remember that technique I mentioned about using the calculator to do the last number? Hey, not enough people are paying attention. Look here, these are very hard. I don't think you cranked on them easily. So let's make sure you're following along. Remember how I said to you, number 4 we're working on now, we have the plan B, I come up with 72. 72 is not the kind of number that most kids have all the factors of 72 off the top of their head. If you do, all the better. But most kids will not. So then you're going to go in your calculator and you're going to type in y equals negative 72 divided by x. And when you do that, you're going to look for a sum of the two numbers of negative 21. And those numbers are negative 24 and positive 3. But because I multiplied by 2 here as part of plan B, what do I have to do a little later? Divide by 2. So I divide both of them by 2. Negative 24 divided by 2 is negative 12. And this is the elementary school trick, 2x plus 3. Okay? Francine, we all right? All right. Any other questions on 1 through 4? Yes?
4 can you do 2x minus 12, or does it have to be the last?
No, you wouldn't be 2x minus 12 because when this reduces, there's no longer a 2 to bring up there. See, the 24 with 2 is 12. You're done. You've reduced it. There's no longer a 2. All right. Any other questions? All right. So now let's take a look at the original question from Sam. Solve for x. 2x squared plus 9 equals negative 9x. Well, the first thing we have to remember is with a quadratic, our solving equation technique is significantly different than it is with a linear equation. Generally speaking, with one exception that we'll talk about in a couple of days, you always want to get everything on the side of the variable. So I'm going to get 2x squared plus 9x plus 9 equals 0. And when I do that, I notice that, again, there's no common factor, so I go to plan B yet again. Multiplying the 9 by 2, I get x squared plus 9x plus 18. That gives me x plus 6 times x plus 3. But since I multiplied by 2, I have to remember to divide by 2. 6 over 2 is 3, so I get, oh, I made a mental mistake. Yo muy malo. Ready? That's what I get for doing these quickly. All right, we're good here. This is the only, it's the only adjustment we need to make. Hey! All right, there we go. 6 divided by 2 is 3. So then this should be 3, and this should be 3, and this should be 3, and that should be 3. And then this is still 2x plus 3. And this is actually the one I'd like you to focus on for just a minute. Sometimes kids get in the habit, kids are lazy, you know that, right? Yeah, kids are lazy, without a doubt. Your ability to look for shortcuts is a blessing and also a curse. See, after a little while, kids will get to the point where they look at something like this and they see that this is x plus 3 and they go, it's negative 3. And then they'll look at the next one and go, it's negative 3. And the truth is that you can only reverse the signs when the lead coefficient on the x is 1. Otherwise, you would have this subsequent step where you end up dividing by 2. So don't get in the habit of just switching the sign and coming up with the answer, because of the possibility of a lead coefficient other than 1. Okay, so that covers everything on last night's homework that we're going to go over. Now, today's quiz. Good. All right. So, I want to save number 31 or number 1, however you want to look at it, for last, because everybody got it wrong. I do, however, want to go over the other ones. And we're going to do the graph in the whole quiz in exact opposite order. So, number 4. Sam and Jeremy have ages that are consecutive odd integers. Since they're consecutive odd, those things must be whatever variable, and then that variable plus 2. Agree? Okay. It says here they're what? Oh, hey.
What are you doing?
Attitude. Hey! That's twice I hit that. This is ridiculous. There we go. Okay. All right. They're what? They're product. What's product mean? Multiple. What's product mean? Multiply. So I have to do this guy, the j, and then the next one, j plus 2, and I must multiply them. And when I multiply them, I get j squared plus 2j. Distributing, right? A number of people just put j squared plus 2, and they put choice 1. It has to be choice 3. Any questions on number 4? Okay. Now we go up to the next one, the cell phone, and I underlined some very important parts of this question. First off, there's this stuff about a base fee and this stuff about per gigabyte. Which one of those fees is going to repeat or happen over and over and over again? Yeah, the 30 because it's per gigabyte. Okay. Now, since the 30 is the one that's repeating and the 62 is the base fee that you pay only once, it has to be choice 3 or 4. Now the question is, should you do 2 minus g or should you do g minus 2? Because the 30 is only for every gigabyte that exceeds 2. So in my mind, I would say to myself, what if I had 5 gigabytes, right? If I had 5 gigabytes, then 5 gigabytes, I would only, remember, it's only for the part that exceeds 2. If I did 5 gigabytes, how much would I be charged for? I wouldn't be charged for all 5. I'm only charged for the part that exceeds 2. How many? 3. How did I get 3 from 5 and 2? Which one minus which? The 5 minus the 2, right? So if I look here, if I did the first choice, it would be 2 minus 5. That wouldn't work. It has to be the 5 minus the 2. So the correct answer is choice 4. Okay? All right, so there's the first 2 questions on the quiz. Now we go to the first, yeah, you know what I mean. I was extremely happy with how we did on number 2. Did anybody get number 2 wrong? Okay, I don't need to talk about it. You just graph it, right? Good. Now, you know, someone died a couple days ago. David Bowie. Yeah.
Oh, I heard about him.
And, you know, David Bowie was popular when I was young. He was a bit of a trendsetter. I kind of liked the guy. I didn't think he was great. He wasn't no Springsteen, that's for sure. But you've never heard of Bruce Springsteen?
No.
Oh.
But I did just watch Family Ties the other day.
Ah, with Michael J. Fox when he was
With my
young.
mommy.
He played the young Republican, yet he was an extreme Democrat.
Good for him.
Yep. All right, so Bruce Springsteen is super huge, and his respect to music is off the charts. They give HBO specials to him all the time. David Bowie was pretty cool, and he had this song called "Let's Dance." I don't know if you ever heard it.
Maybe if you can continue singing the songs. Like
No, I can't because I don't know the words well enough because Bowie's no Springsteen. And he also had a song called "Fame," and his most famous one was about Major Tom.
Who's Major Tom?
Oh, you have to hear the song Major Tom. Major Tom's a classic. It's a great song. Commencing countdown, engines on. And then he blasts off into space and he goes, "This is ground control to Major Tom." It's just a great song. If I get a chance, I'll play a little of that before the end of the period. It's a classic, absolute classic song. Anyway, as I was writing this and I wrote, "Let's graph," I thought of "Let's Dance," the old song by David Bowie. I think it was by Bowie. It might have been by the Kings, but I think it was by Bowie. So anyway, we're going to graph this guy and get this right. So here we go. Ba-ba-da-ba-ba-ba-ba-ba.
I tried that.
Good. If you tried graphing it, you were doing the right idea. Oh, no, hold it, we're gonna clear this. What is this function again that we're doing? Negative 16t squared plus 64t? Okay, ready? Negative 16t squared plus 64t.
X.
Yeah, well, that's same thing. Graph. Okay. Now, let's do a little exercise in understanding our calculator and the power of the calculator. The first thing that I want to do is I want to change the window because I clearly don't need negative time here. Okay? And I don't need down here because that's when it would be under the earth. So I go to window, and the x minimum I'm going to change to -1. And the x maximum, 10 was good, it all fit on there. So the x scale is 1. The y minimum, I could go to -1 again. The only reason I do -1 instead of 0 is so I could see the axis. If I didn't care about seeing the axis, I would put 0. Okay. And let's see here. Y maximum, well, clearly that wasn't tall enough, so I'm just going to go to 50. And yeah, let's see if it fits. I don't even know if it's going to. Oh, it almost fits. Well, this is good enough. Can we all see that the ball is going to go like this?
Yeah.
Okay. The rocket is going to go like this. Now, we're back in Mr. Golden's class. What is the domain, x or y? X. Domain is the set of all
X's.
inputs, x's, etc., etc. So the domain is the set of integers. And when we talk about looking at a graph and trying to determine the domain from the graph, what we said to you, God bless, is that it's as if you compress the graph onto the x-axis. And whatever part of that axis is covered by the graph is going to be the domain, because you just said to me, domain is input, which is x. So imagine if I took my work boot and I stepped on the top of this parabola and I squished it down. Isn't it obvious that it would squish right to there?
Pretty much.
Right? Okay. Now, what values of x are we looking at? What's the smallest value of x? 0. What's the biggest value of x? No. Where does it stop? Right there. 4.
4. Oh, I thought we were talking about like up there.
No, 4, because even, let's look at the table, okay? Let's take a look at the table here. Here we go. Second table. Now, we just said that we can't have a negative height. And all of these values here are negative. Now with 0, I can be at a height of 0. That means I'm just laying on the ground. And then I'm going to go up. That's looking good. That's looking good. I'm back down to 0. So clearly this is okay because I have positive heights. So that from 0 to 4 looks good. As soon as I go past 4, I'm back into the negatives again. But a rocket doesn't burrow through the ground. It stops when it hits the ground. So what is the domain? And this is a little bit of the dangerous part here. The domain is going to be right here. But the dangerous part is, look, they don't put every single number in the table. But the truth is that when I graph this guy, there is the rocket, even at the half second, the rocket is at a particular height. Even at 2 1/4 seconds, it's at a particular height. So the domain is all the x's from when it starts to when it hits the ground, stops, ends, whatever. And what x's are those? Those are all the x's that go from 0 to 4. And I can write that 2 ways. Or that way. Now, a number of people did write on their paper 1, 2, 3, 4. So they had an idea. They're going in the right direction, but they were a little bit faulty on how they expressed their answer. Generally speaking, if I'm going to ask you about a domain, unless there's something very strange going on, the answer will always begin with this. X, because domain is X, and this is bounded by or in between. And your job is to figure out what's the smallest value and what's the biggest value.
And it's always going to be both sides.
Yes. Okay? So that's how we handle a question like number 1. As always, you go home tonight, you do your homework, and before you start your homework, you look this question over for a minute or two, then you do the same thing afterwards. Okay. Now, let's take a look at today's do it question. Now, we are fully functional with how, thank you, we are fully functional, go ahead, with how we handle quadratic equations. We know how to do those. And we are now taking it up to the next step. BAM, as Emerald would say. We're kicking it up a notch. And the way we're kicking it up a notch is we're taking how we know how to solve quadratic equations. We're going to apply it to the world of word problems. Now, yesterday we never got to do the do it question that was based on word problems. So we will do this one now. Then we'll do the second one on our sheet now, and then we will, if we have time, backcast and cover yesterday's. So, find 2 consecutive odd integers whose product is 99. Now, as soon as that says consecutive odd integers, what are you thinking? Go ahead. Okay, good. And I would go so far as to say first consecutive odd integer and second consecutive odd integer, and as Hunter said, x and x plus 2. And then, what is, other than the phrase consecutive odd integers, what's the most important word in that problem? Blah, 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 blah. Product. Product means what again, guys?
Multiply.
Multiply. So I got to do x times x plus 2, and I have to get 99. So I think it's pretty obvious that the first step is to distribute the x, right? So there you go. I'm going to get x squared plus 2x equals 99. Now, at this point in time, this looks like the last couple days do its and ours. And at this point, you should be very comfortable. The only new thing we're doing today is everything prior to this. Okay? What's my first step in solving this quadratic equation? Get the 99 on the other side. Very good. So I minus 99 from both sides. That gives me x squared plus 2x minus 99 equals 0. So now, using the AM technique, I want 2 numbers that multiply out to... No, you're ahead of me. 2 numbers that multiply out to... negative 99 and add up to... 2. Now, Ivy, you're on. Go ahead, step it up. What are they? That's right. So now we factor with x plus 11 times x minus 9 equals 0. Who wants to know how to cheat?
I do.
Go ahead, raise your hand if you want to cheat. I want to smell a smelly room. Okay. There's another way to do this, in case you're having a hard time factoring it. If you ever have one of those moments, let's go back to the graph, and let's go to y equals, okay? And I'm going to clear that out, and everybody type in x squared plus 11x minus, plus 2x minus 99. X squared plus 2x minus 99. And then hit graph. And no, this should not say error. Now, I would also like you to go to Zoom 6. Zoom 6 puts it back in the original area. Okay. Now, listen. Is it pretty obvious, like this is 1/2 of the parabola over here? Right, and we're missing the other half, and the other half has to be on the other side. So I'm just going to go out wider on my window. So window, and then for my x minimum, I'm going to go negative 20. And then hit graph again. And there we go. Now, I'm sure you understand that beneath here is where the parabola turns. Everybody watching my finger? Okay, good. So, listen, the solutions are the zeros. In other words, if you have a really hard time factoring it, just graph the thing, and then say to yourself, where do I hit the axis? I hit the axis here and here. Well, Guess what this number is? This number is negative 11. Guess what this number is?
Positive 9.
Positive 9, yes. So I have negative 11 and I have positive 9. Now, another way to do it, because we're solving for where it equals 0, would be to instead look at the table. And I'm just going to look for wherever it equals 0. All right, see here how it says 9, 0?
Yeah.
Done.
Boom.
So an answer is 9. And if you go in the other direction, you'll come up with negative 11.
Let's
Okay?
do it.
God bless.
Okay.
So I don't want you to rely on your graphing calculator to be able to get that answer by factoring, but I do want you to understand that if you're absolutely stuck, you can always graph the thing and come up with the solution. And you can also look at the table to come up with the solution. Now, going back to what we have here, the last thing I do to finish off this problem is I do maybe it's the guy on the left, and maybe it's the guy on the right. Minus 11, x is negative 11, add 9, x is 9. Now, the only thing is, each of them has a pair. If this is negative 11, what's negative 11 plus 2? Negative 9. If this is 9, what's 9 plus 2? 11. Now, the coup d'etat, the creme de la creme, the piece de resistance, is to look at this and say, what is 9 times 11? 99. What is negative 11 times negative 9? Ha! In your mathematical face. I got it. Okay?
Wait.
I just checked. It said that the product is 99. They multiply out to 99. These two multiply out to 99. So notice what it says over here. Note there are two different pairs. Here's one pair, and here is the other pair. Remember, this is a quadratic. Quadratics, unless it's a rare circumstance, quadratics will have two answers every time. Okay? All right. So, are there any questions about this? Let's play. The larger of two integers is 1 less than twice the smaller. The product is 28. Find both integers. Begin. If you're a little stuck, feel free to talk to the person around you. Are you stuck or is it that easy? Well, you're allowed to not like it. That doesn't mean you don't do it. I assure you, I don't like to pay taxes. I'm really not big on it. But I do it anyway. Okay, so the larger of two integers is 1 less than twice the smaller. The product is 28. Find both integers. What's the first integer always going to be?
X.
Nice. What's the larger integer going to be?
2x minus 1.
Nice. 2x minus 1 is correct.
I got you.
Now, what's the next key word in there that's so very important? Someone other than Sophie. Yes. Product. That means
Multiply.
multiply. So x times 2x minus 1 equals what?
28.
28.
Should I raise my hand?
So how do you think you do here? What do you do next?
You distribute.
Distribute. Good. What's x times 2x?
2x squared.
2x squared. X times negative 1?
No.
Negative x equals 28. Now, I'm going to pause for a moment because I want the wimpy one to get a moment to work this out a little bit and make sure she handles it okay rather than be wimpy.
Are you supposed to look for a common factor first? Or?
Well, first you want to get it all on one side.
Oh, okay.
That's always the first step with a quadratic, at least for now. And then you want to look for a quadratic or a common factor. And if there is no common factor, we go to
Plan B.
Plan B.
Plan B.
Very good.
I just hate it when it's negative x. Just make it negative 1x.
Well, I don't care. Yeah, you can write negative 1x if you
I know,
want.
that's what
Yeah, the really ones to hate are when it's negative x squared. That's the ones to hate.
Wait. Did that. Oh.
Everybody realize we have to plan B?
Yeah.
Okay. So I get x squared minus x minus 56 equals 0. When I factor that, what do I get? Good, x minus 8x plus 7. As always, if you get a little stuck on that 56, and 56 seems to be a number over the years I've seen many kids struggle with, y equals negative 56 divided by x. Look in the table, find the two numbers that add up to negative 1. Maybe it's the guy on the left. Maybe it's what? The guy on the right.
Do we have to divide?
Yo, muy malo.
That's where.
Divide back in by 2. X minus 4, apparently Hunter forgot also. 2x plus
Hunter?
7 equals 0. Maybe it's the guy on the left. Maybe it's the guy on the right. X equals 4 minus 7 minus 7. 2x equals negative 7 divided by 2. X is negative 3.5. Now, would somebody please read the first 5 words of this question? Ivy,
The larger of two integers.
stop. What was that last word? That means one of these must be rejected.
Obviously,
Which
it has to
one-
be the negative separation.
Why is it? Because it's negative?
It's not a whole number.
Because, right, it's not an integer. Integers are not fractional parts, so that's gone. So the only answer here is 4, and 2 times 4 is 8, minus 1 is 7. And hey, check it out. What's 4 times 7?
I did not do that right.
28.
That's where I got it.
Listen, it's very normal at this stage to struggle a little with the word problems. They are brand spanking new to you. It is okay. Just keep fighting your way through them. In a couple of days, you'll be very good at them. Yes.
Like, I just.
It's my different mode.
Yeah, show me at lunch.
Are you excited?
Okay?
I won't remember.
No.